Hey everyone, today I want to talk about the geometric representation of complex numbers. So first, let's talk about the geometric representation of real numbers, and that'll lead us really nicely into our discussion about complex numbers. So how do we geometrically represent a real number? Well, let's say we've got some real number, let's say the number 2, and we want to represent this. Well, all we have to do is simply plot it on a number line, right? So let's go ahead and draw in our number line. Let's say this is 0, 1, 2, 3, and we've got -1, -2, and -3. Well, all we have to do is simply just draw a point here at 2, and that's our visual representation of 2. Real numbers are just a one-dimensional quantity. There's only one value that needs to be represented. But if we think about complex numbers, let's say we have a number like 1 plus I, well, we can't represent 1 plus I on this one-dimensional number line because we have a real and an imaginary part. So we could plot the real part here at 1, but where do we plot I? Well, there's no place to do that here on this one-dimensional number line. So in order to geometrically represent complex numbers, we're going to need two axes to do this. We're going to need a real and an imaginary axis. So let's go ahead and draw that in. So let's make the horizontal axis the real axis, and we're going to label it RE. This is how it's typically labeled. And then we're going to have an imaginary axis as the vertical axis, and this is going to be labeled IM. Now, something I want to point out here is that the real axis is simply just the set of real numbers, and this actually means that the real numbers are a subset of the complex numbers, right? Because all a real number is simply a complex number with a zero imaginary part. So for example, if you wanted to represent 1 as a complex number, it would simply be 1 plus 0i. It's just the number 1, and then the imaginary part is 0. So yeah, that's something important I just wanted to point out really quick, is that the real numbers are a subset of the complex numbers. All right, so now that we have that out of the way, let's go ahead and put some units on here. So remember, the real axis is simply just the set of real numbers. So let's just put in 1, 2, 3, and 4. -1, -2, -3, -4. Now, what do we put on the imaginary axis? Well, we're going to put in I, 2i, 3i, and so on. And then down here we have -I, -2i, -3i, and so on. Okay, so this is the complex plane. We've got our real axis and our imaginary axis. But how do we represent our complex number on this plane? Well, typically complex numbers are represented as vectors. So let's say we have a complex number z1, and it's equal to 2 plus I. Well, how do we represent this? Well, let's just draw in the vector down on the complex plane. So let's start at the origin, and notice that the real part is 2, so we need to go 2 in the real direction, 1, 2. Okay, now let's look at the imaginary part. The imaginary part is 1, because we just have I, which is being multiplied by 1, but you just can't see it. So we need to move 1 in the imaginary direction, right here. So this is where the tip of our vector is going to lie. So let's go ahead and go to the origin and then draw our vector in. Perfect. Now this is the visual representation of z1 on the complex plane. It's simply a vector that conveys the information of the real and the imaginary part. Let me label it z1. Okay, perfect. Now let's go ahead and do another example. Let's say we have a complex number z2, and this one is equal to -3 plus I. Okay, so let's go through the same process. Let's go to the origin, and we need to move -3 in the real direction because that's the real part of z2. So let's move over to -3, and then we need to move 1 in the imaginary direction because that's the number being multiplied by I. That's the imaginary part of z2. So let's move 1 in the imaginary direction. Perfect. So this is where the tip of our vector is going to lie. Let's go ahead and draw it in. Awesome. So this is Z2 represented visually. Now, one last thing I wanted to discuss is the visual interpretation of complex addition because it ends up working out really intuitively here on the complex plane. So let's say we now want to represent z1 plus z2. How exactly can we do this? Well, let's simply move z2 over to z1. So let's put the tail of z2 on the tip of z1, and that's actually going to give us z1 plus z2. So let's go ahead and move it over. So z2, remember, moves -3 in the real direction and 1 in the imaginary direction. So if we start at z1 and we move -3 in the real direction, that's going to bring us to -1. And then if we move 1 in the imaginary direction, that's going to move us to 2i. So let's go ahead and draw in the tip of our vector. And if we start at the origin and draw our vector out to this point, this is z1 plus z2. And that is how you represent complex numbers visually on the complex plane. In the next video, I want to go ahead and discuss the argument and the modulus of complex numbers. See ya.